What do Copper Alloys Limited do? Casting, forging, machining. We melt and pour metal on site. We work the metal to make it better, from which we make components and mechanical equipment, any shape, any size, any spec. The more complicated, the better.
For decades, Copper Alloys has spearheaded the development of advanced material technology. Today we are showcasing the range of elite alloys, a number of which have been specifically designed to outperform anything on the market for seawater applications. Copper Alloys has developed a whole raft of technology that has had multiple specifications and has been endorsed by governments and OEMs and design engineers around the world. One of these alloys is called copper nickel chromium. That's a typical 70-30 copper nickel with the addition of chromium. This chromium addition really makes all the difference and enables the material to last up to 50 years in seawater. How do we know that? Well, we've partnered up with the British Corrosion Research Organisation, and we have developed the British Corrosion Project, which is designed at comparing a whole range of marine alloys in the same environment and looking at the mechanical properties, the degradation of those over time, and also their ability to withstand seawater and crevice corrosion. There are 3 racks of samples, one at a marina, one out at sea, and one in high sulfide, low oxygen environment. You can see that there are 28 different alloys, and these pictures show the effect after 22 months of immersion. The project is a 10-year project. Now we are into our 7th year, and we have pulled 2 of the test racks up. These are the results after the first test rig was pulled up. 4 years of immersion shows that copper nickel chromium performed the best of all of the copper-based alloys. The advantage the copper-based alloys have to all of the other marine alloys is that they are naturally resistant to biofouling. Here we can see that typically for a lot of the stainless steels, pitting corrosion was found throughout the samples. Some of this was dramatic. After only 4 years, the material had pretty much wasted away and undermined all mechanical strength and structure in the section of the material. Here we have the percentage metal loss over the 4-year time frame of all of these alloys. We can see that some of the alloys in particular were very, very good, and some were surprisingly poor. So this was the galvanic comparison. So every other alloy was galvanically coupled with copper nickel chromium to assess the compatibility. And we can see that everything in blue would be classed as compatible with copper nickel chromium. This is what a component made out of copper nickel chromium looks like after 10 years of service in a submarine. They took it out of service, they shot blasted it and cleaned it, and they put it back into service because they had identified 0.15 millimeters corrosion in 10 years, which enabled them just to put the component straight back into service without having to purchase a new one, saving time and money and the effect on the environment. So what does this mean? We can expect with these alloys in constant immersion of seawater, whether it's crevice or general corrosion, of less than 0.02 millimeters per year. These materials are also low in potential, which means that their galvanic interaction is normally excellent with more noble metals. There's no selective phase corrosion, so the rate at which the corrosion occurs is consistent, unlike some other alloys where they can be variable. There are a range of other additional benefits as well. Mechanically, we found that there wasn't much of an impact of the corrosion on the mechanical strength, unless obviously the degradation had happened throughout the section, weakening the material itself. So typically we have a range of cupronickel that have been used in seawater environments for a long time, and the issue we have is that a lot of them are low strength. Here we have a typical corrosion rate of flow rate, so impingement rate of copper nickel chromium versus 70-30 cupronickel. One of the advantages we can see is that the flow rate that you can put through tubes on the copper nickel chromium is much higher, and therefore systems can be more efficient. The strength of copper nickel chromium is quite interesting. Should enable people and engineers to design lighter, lower cost components because of the mechanical strength of the material. It rivals that of a 316 stainless steel. So when we are designing marine components and equipment and systems, the first thing to consider is whether we want this thing to last. How much of an impact does it need on the environment? A lot of systems are expected to last 1 or 2 years in seawater, and then they'll get destroyed or thrown away and replaced. We believe in designing systems to last as long as possible. And the metal here, copper nickel chromium, which is just one of 3 elite marine alloys. These alloys enable systems and components to last decades in seawater, especially because the ability of copper-based alloys to resist biofouling enables low maintenance as well. So there are some long-term through-life advantages in upgrading material technology to one of the elite alloys. What range? How can these things be made? Well, there's an enormous scope, up to 20,000 kilos in a single component, all the way down to small washers and bearings and bolts. All of that scope is possible. Copper Alloys offers a complete service, so we'll support your engineers in designing the best possible component, and then we will produce the metal. We have furnaces. We are making 250 different alloys, and those then once the furnaces are used, they cast the material, we'll forge it to get the mechanical strength, and then we can machine to print. So there's a whole range of possibilities here for marine engineers, and especially in aquaculture, as plans to scale up the scope of some of the farms and some of the capacity that we see around us. Now is the time to plan for the future, to make the systems more reliable and reduce maintenance and the effect on the environment by specifying materials that last longer in seawater. For more information, see www.elite-alloys.com or phone up one of our metallurgists or material engineers from copperalloys.net. Thank you.
Copper alloys specialise in taking the stress out of critical complex components that are built to print. What does Copper Alloys do that's different? We save engineers around the world money, time and resource by working closely with their engineers to enhance material selection decisions and take the hassle out of sourcing complex turnkey components. To do this effectively, this process begins with design for manufacture. There are 3 distinct areas that Copper Alloys has invested in to create class-leading performance. 1. Unique design support. optimize material selection at design stage to engineer out cost and improve performance and reliability. Develop new material technology, designing metals to last 50 years in seawater, fit and forget. 2. Customize advanced production solutions, complex critical components and assemblies built to print. Project management of additional processes, e.g. coating, painting, welding, testing. 3. We get it right. Over 1,000 nuclear submarine first-level components delivered this year. 0 defects and all on time. Copper alloys ensure customer satisfaction by hands-on expert control of special engineering processes, outperforming the rest. A unique approach to risk control and attention to detail ensures successful projects completed on time and in budget. Risk is managed to death through a proven supply chain by the unique Copper Alloys project management tool workflow that is so on the ball it predicts schedule impacts months in advance, so we have plenty of time to do something about it. Copper Alloys offers a fully integrated service from material creation to mechanical assemblies. From a customer point of view, it's seamless, like the documentation packs. Our customers say they don't see and feel the work and effort it takes to make things happen. With Copper Alloys, they just happen. It's a turnkey solution.
Why buy from Copper Alloys? Copper Alloys is a fully integrated engineering partner, a one-stop shop able to handle the most complex of engineered components, controlling vast supply chains to ensure that special processes such as machining and coating are handled with care. Copper Alloys are experts in metallurgy and material technology. With on-site production, our highly trained team can tailor the manufacturing of metals to enhance properties and reduce the cost of producing components. Buying components direct from the mill will benefit the environment and your supply chain. For example, machining swarf is captured and recycled and then credited against the job to reduce the cost for the customer and the environment. Make life easier when it comes to complex components. Let Copper Alloys do the hard work.
We started as a continuous casting company and then moved on into wrought products, and that's where it currently is today.
At Copper Alloys, our business, we serve customers in all sorts of industrial sectors. We provide them with raw materials, metals and alloys that go into components in equipment that our customers manufacture.
So the way we approach everything is we try and make our processes as homogeneous as we can. We try and make it so when we repeat the same process, as many variables are controlled within a narrow margin as possible to move them into the successful window. We do things here like continuous casting, and there's a huge number of variables in continuous casting. And the key is really to home in on the ones that work and really capture them and repeat them, using different alloys, using different heat treatments, different forging processes, that sort of thing, and we can really target our production towards what the customer hopes to achieve with it.
Cast metals tend to be weaker, the properties aren't homogeneous throughout the component, whereby you go to a forged product and we have much higher properties, higher strength, higher toughness, greater hardness and integrity.
We follow strict guidelines, strict procedures and specifications, both in-house and external, and everything is certified as per them specifications. If it doesn't meet, it doesn't go. We use ultrasonic testing, visual testing and liquid penetrant inspection.
We've got quite an extensive range of machines. We do everything from turning, milling, CNC machining centres, specialist broaching applications, splining. We've got the resource to tap into all of those machining applications. We've got a very, very close control in terms of the suppliers we use, and we've been very selective in suppliers we use delivering to us and how we then handle machining of components. So in everything we do in terms of machining, we are looking at ways to de-risk the actual processes to ensure we achieve a finished product right first time.